right. We talked a lot about color now, color and color quality, but of course if we talk about light, there's also more important to know. And so, is there anybody in here who can explain what this slide shows us? Show some basic light values, the lumen. So otherwise I will explain a little bit. If we talk about color is the one thing of light, but we also usually want to know how much light we get. So the first thing that we can have a look at is the luminous flux. Lumen, this is all the light that we get. If we have a tungsten bulb, if we have a LED, doesn't matter. All the light that we get from the unit are the lumen. Usually, we are more, because we use the light or the fixture to light certain things. So what is more interesting for us is this, the luminosity, measured in candela. This is the amount of light that a fixture, for example, sends to a certain direction. Usually we talk about the light that is like straight in the front. So all the light the fixture sends to here is measured in candela. And then, of course, what we really want to know is how much light do we get when we, for example, light an actor or light some parts of our scenery. And this is measured in lux, the illuminance lux. So you might know about these measurement tools. You can just go close to the actor, measure, okay, I get so many lux. So I know how much light I get. And this value, the illuminance, of course, it depends on the distance. So if we have the fixture here, of course, and light, for example, the actor. And of course, if he's like here, he's like 1 meter away from the fixture. He gets a certain amount of lux. And now he moves 1 meter to the right, 2 meter distance. Of course, he has less light. But how much less light? How much lux do we lose if we double the distance? There's a rule of thumb. You lose a quarter or you still have a quarter? No, you still have. You lose 3/4. Yes. Yes. So you lose much light. Yeah. If you double the distance, you only have quarter of the light intensity. Yeah. As a rule of thumb. It depends a little bit what kind of fixture you have, but usually for your everyday work, it's okay just to know about it. And this is very important if we talk about lighting design. It's the, how is it told in English? The photometric rule of square, like this, because you lose in square, you lose light, lux in square. And this is very important, because often it can be a problem that your fixtures are too close to the set, and of course actors move, and then it looks strange if they lose so much light. Yeah. Very important to always think about this rule. Of course, these measurement tools, they can also directly show you which f-stop you have to use for the camera. So usually we're talking about f-stops, we don't talk about lux if we are in the movie business. Yeah. Just to know about that. One more important thing to know, if we compare fixtures, and like fixture A has 1,000 candela and fixture B has like 2,000 candela. It doesn't say too much about how powerful this unit is, because fixtures, of course, they spread the light in different ways. Yeah, like one fixture can be like a direct source which has really a strong light, like nearly parallel beam. Of course, this is much stronger, has a much bigger amount of candelas. And the other fixture, maybe it's like a more like a floodlight. Of course, like we have light like everywhere, but not such strong. It's not like to get a really big throw for the distance. So if we compare fixtures, it's not enough to just look at how much candela do we get. You should always have a look at these charts. This chart shows you what the fixture is doing with the light, how it distributes the light. For example, here, this fixture, at 0 degree, this means like the front. This fixture sends more light to the side, to the right angles, than it sends to the front. So this is a very special fixture. It's like a really strong floodlight, which can illuminate a big scenery in a very short distance. Typical floodlight. Other fixtures, like for example these, Fresnel spotlight, you will see a completely different curve, which is maybe like this. And of course, because it's focusable, you have two different curves, one for the flood and one for spot. So if we compare fixtures, always have a look at this, because otherwise it doesn't tell you anything. If you only look at the candela, it doesn't give you all information that you need to judge about the fixture. Last thing, especially if we talk about LED, one main advantage of LED is that they are very efficient. Efficient, or efficiency, what does it mean? Very simple. How much light do I get for the electric power I put inside the fixture? That is efficiency, and it's measured in lumen per watt. So in the next slides, you will often see a value for lumen per watt, and this says you how efficient this technology works. Okay, so words about the light technologies. We start with tungsten, tungsten halogen, different to the tungsten that you maybe still have at home for your normal ambient light. In the movie business, we use tungsten halogen. And as we know, tungsten is not such an efficient technology. So what would you guess? If we use a tungsten unit, how much energy is transferred to only heat? 95. Say 95? That's close, it's 90. 95 is true if we talk about like the conventional tungsten you have at home. If we talk about tungsten halogen, like the bulbs that we have in here, they are a little bit more efficient. But as you see, I mean, 90 or 95, it's still not very efficient. Yeah? So this is one of the big disadvantages of tungsten. I once made this measurement spectrum of the tungsten bulb, but not only the visible part. We were able to also measure these, the infrared, the heat. So all what is here in dark red, it's all heat. So also here we see mostly what we get from tungsten is heat. I have made this small overview to, yes, as you see. There are also some advantages of tungsten, of course. We still sell tungsten. Many people still use tungsten. One reason is it's very cheap technology. We have a very good color quality if you work with tungsten. And they're also dimmable, especially for studios. Studios around the world used to work with tungsten because they are dimmable. Now they switch to LED because LED is also dimmable. And the good thing about LED, they can be dimmed without any color shift. So, as you might know, if we, like here we have tungsten unit, area light, 50, and now it's like full power, and if I dim it, you see it not only gets darker, also change the color, yeah, very strongly. And this will not happen if you work with LEDs. Okay, but still, it's still an important technology. It's still used everywhere. It depends what you expect from your unit. it's sometimes also still tungsten is a good choice. Next technology, HMI daylight. This is a very, very, very important technology, especially for the movie industry. These are the most powerful light bulbs that we have, most powerful lamps. And if we have a look at the spectrum here, HMI looks, of course, different to what we have seen from tungsten. More blue light in here, less red parts, of course, because these are called daylight. And we have all these little spikes in here. So it's not as flat as we have seen from the tungsten, but these spikes are not a big problem for color quality. They are too small, too spiky, it's not a really problem. Yeah? HMI has a good color quality, because if we see here, there are no big gaps or something like this. Every part of the spectrum is here, but also with HMI, we have a certain amount of heat. Yeah? All this part is heat. It's not as bad as with tungsten, but it's still there. And also important, this part, like here, dark purple, this is UV. Yeah. Very important to know, HMI produces also UV, dangerous UV. So it's very important that all the fixtures, we have the HMIs over there, all they have a protection class, UV protection. Because this is not the nice UV that gets you brown skin, it's really dangerous. So we have to use protection glass. As we see, HMIs don't produce so much heat. They are much more efficient than tungsten. So what? Maybe you know it. It's not a secret. How much more efficient or how much brighter is an HMI compared to tungsten? Roundabout?
4 times.
Yeah, correct. 4 times. Roundabout. So this is HMI. Later. HMI is not the cheapest technology. Yeah? It's compared to tungsten really, really expensive. But it's so efficient, 4 times brighter. And if you think about movie production, and we have to deal with sunlight, daylight that is coming from the window, and we need some tool to have a little bit fill light to like I showed in one of the first slides, to even out the contrast, then it's very, very difficult to do it with tungsten. You would need such a powerful tungsten unit, and of course you want to have it in daylight color temperature. So you have to convert the tungsten. As I showed you, full convert from tungsten to daylight would mean that you lose 2/3 of the light intensity with the tungsten. So if you think about that, if you want to work in daylight, and you often have, the sun is daylight, then you're not talking about 4 times brighter. If we talk about daylight color temperature, the HMI, because we don't need to convert it, it's already daylight, it's 12 times brighter. So there's nearly no way to get around using HMI. We have to use HMI, and they are used like around the world. HMI, how do they work? Just want to switch on one of the units. This is an 800 watt HMI unit, ARRI M8. It's our newest HMI fixture. It's a quite small unit, but very powerful. As I said, if we talk about daylight, 12 times more efficient than tungsten. So this small unit you could compare it to nearly a 10K tungsten, if we talk about daylight. And what you also recognize, it takes some time. I switched it on, and HMI, they always take some time until you have the full light output, the full power of the unit. As I wrote here, around 3 to 5 minutes. And this is like typical for every HMI. It takes some time. I will switch it off because I think it's hard to to follow or to see the slides. And the reason for this is HMI lamps, they don't have this filament like a tungsten bulb. They have 2 electrodes, and we have to first, there needs to be an ignition, a ray of light from this to this electrode. This is first, so we have this ignition with a very, very high voltage, and after this, the system starts to build up. It gets warm, it gets hotter, and it would run forever if we don't limit the current. If we don't limit the current, the system would run forever, and at one point it would just explode. Yeah. To limit the current, we need ballasts. Like if you have a close look, all these fixtures there, they have a ballast. Somewhere these blue boxes, or here it's the silver box. This is necessary for every HMI around the world. Different types of ballasts. These control the current. You can also use these ballasts, if they are modern ballasts, to dim the HMI a little bit. HMI are dimmable, but not as good as tungsten. How much can you dim an HMI? 50%. Yeah, around 50%, true, yeah. So that's at least an option to dim the light, but it's not as flexible as with, for example, tungsten or even LED. This is how HMIs work. So if we compare all this, or if we line it up, HMIs, very, very efficient, high power units. ARRI uses HMI up to 18,000 watts, so really powerful units. And but on the downside, expensive. We always need a ballast. We have the run-up time, as you see. It's not like tungsten, you switch it on, you have the light instantly. So pros and cons, like everywhere, but especially for the movie industry, it's a technology that is, it's not able to think of a world without this technology. And if we think now about LED, because the next slides will be about LED, it is not possible to use LEDs to get this power of an HMI. If it's a bigger HMI unit, like we have the other 1800 watt HMI, or if we talk about the 4K, 6K HMI, LEDs are very, very, very far away to get this light power. So if anybody tells you about, whoa, I have a LED unit and it's powerful as, let's say, 4K HMI, that's not possible. Yeah, not at all.